Hi, my name's Chris Allan, and I'm here to talk today about a recent project where we took one of our major products and completely changed the way our approach to automated testing and describe some of the effects that had on the sort of internal product architecture itself. So first, very little bit about me. So I'm currently a software architect with Experian Data Quality. I've been doing this kind of work for about 15 years, starting off in test automation as a junior engineer, and since then had a variety of sort of different roles, both management and as an individual contributor. I've also been involved in the past doing due diligence for potentially acquiring software companies, which given me quite a broad range of working with different teams, understanding what works and what doesn't. So to begin with, I just want to describe the product I'm going to talk about a little bit. We don't have too much time, but there's really just two things we need to know about it. One is that under the covers, it's really a database engine. So doing very similar things to relational database engines in terms of storing tabular data, managing duplication on disk, and then transforming and combining it in different ways. So aggregations, joins, filters, transformations, all that sort of thing. The second part, as you can see from the screenshot, and this is what differentiates us from other database engines, along with other things, is you actually construct queries by drawing these flowcharts. We call them workflows. So rather than typing in SQL queries, which obviously requires some level of deep level of technical ability, people can describe the transformations graphically, and that allows a much wider range of users to create some pretty complex database queries. These two parts are tied together pretty fundamentally. So as you're changing this diagram and clicking around on the screen, the queries that are executing are changed on the fly to ensure that you see instant results of every change you make. So I'm going to start with a little bit of history of the product. It was actually created by a startup back in 2008, so outside Experian, where I work for now. Although what you just saw was a web application, it started life as a rich desktop client application connected to a central server via the network. So quite different in terms of the application functionality. And because it was a startup, they had some pretty short-term objectives. They needed to prove the concept, acquire some customers, and then ideally sell the company, make some money. So what that meant was they were much more focused on the sort of 6-month, 2-year time horizon than considering questions like where would their automation test frameworks be in 2020, which is the question we've had to look at more recently. The product was really successful, and almost a decade later, it pivoted to some extent, renamed Data Studio, and that's where that graphical web-based UI was introduced. But despite that change, the internal architecture was actually pretty similar. So obviously changes did need to be made, but it wasn't a rewrite, it wasn't a new product. It was that sort of client-server transitioned to become more of a web-based interface. And there's just one technical detail I want to talk about because it's very relevant to what I'm going to say later, which is all the communication between the server and the client is via WebSockets. So the server held all the state, and then the JavaScript running in the browser would send a continuous stream of events describing things like where the user clicked their mouse, where the mouse position currently was, were they dragging, and then the server sent back a sequence of updates to say, here's how you should update this diagram. Or if the browser said the user has just scrolled a grid of data and these 2 rows are now visible, the server would calculate the results for those rows and send them back cell by cell. So a stream of very frequent messages going back and forth in both directions. Because we're going to be focusing on testing, I just want to describe some of the main testing challenges, the 2 main ones. The first, that testing any database engine is really tough. The user can bring in any data, any formats, any data types, any schemas, and then combine them in millions of different ways, whether it's joining in different ways, transforming them in different ways, aggregating in different ways. And all these operations can obviously be combined. So there's a sort of combinatorial explosion there in terms of testing, and also sort of some pretty tough performance requirements. The other bit is the rich diagramming. So easy enough to test interactively by hand, but to write automated tests to make sure that diagrams are getting updated smoothly and there's no lag and that things look good visually is very tricky. So this is where we were in about 2018. We had a very successful product that did been going for a decade. But there wasn't full test coverage because of that early focus on getting product market fit. And the architecture, while great for a client-server app, had become slightly out of alignment with the way the product was. And we were looking to change that to make it more appropriate for a web-based application. Changing topics slightly, I want to talk about two different styles of software development, both of which I've seen work to deliver high quality software. First, I'm going to call the team of experts approach. So this is where you get an experienced small team building the software. That gives you the luxury of creating a targeted approach to test automation, by which I mean rather than aiming to get 100% coverage and test everything, you work out where you get the biggest bang for buck and test specific components, and then rely on a risk-based approach to regression testing. So if you've got a small team, you know exactly what's changed, you know which test cases are worth running and which you can skip for every release. And initially it lets you move more quickly. But there are some downsides to this. So inevitably, whenever you do a release, you need some period of code freeze, sort of allow stability for manual testing. You don't want to be running test cases if the code base is changing daily. And that leads to you getting some efficiencies by putting features together into bigger releases. So you can change the ratio of time developing features versus running regression tests, which means you have a longer period of time between releases than you otherwise would, and you need to plan your roadmap longer in advance. And these problems can actually get worse over time because as the amount of existing functionality increases, the number of regression tests worth running increases and tests take longer. The second thing that happens is it all relies on developers and QA really knowing the product well. And that makes it hard to scale the team quickly because you've got to train everyone up and they've got to get familiar. And of course that means it's hard to increase scope of the product if you can't add new team members and new teams. The second approach I'm calling safety and test automation. So this is really where you have so many tests and so much coverage. Anything that passes the automated test suite, you basically know works and you're happy to release it to customers. It tends to go hand in hand with continuous integration approaches and the use of things like feature flags, as opposed to long-running feature branches. Because to be honest, if you spent 4 months working on a feature branch and then you merge it in, that integration is probably going to be painful enough and take a few weeks. All you've really achieved is taking what you were calling code freezes and now calling something along the lines of an integration sprint. But unless you change all your processes to match, you certainly don't get all the benefits. But the upside of this is if you do trust that your tests will catch all the errors, a lot less risk in bringing people in, and you can really scale the teams faster, scale the scope of the product faster. So as I say, both of these worked. I've seen them both work. But if I was going to start a new project today, even as a small startup in the conditions described earlier, I'd go with this second approach. And the reason for that is that it's really hard to change between the two. There are a few reasons for that. So the first is that whatever your current process is, there are going to be virtuous cycles in there. And what I mean by that is that whether it's you design, you're estimating, you're coding, you're planning the tests, all of these will have evolved to work well together. So you can really think of this as a kind of process optimization. So if we imagine here, the y-axis is process efficiency, and you can move along this line. And what's going to happen to any team is that they're slowly going to get better, whether that's using a process like Kanban, where you're very explicit about it, or just making decisions at the end of each retro to improve things. Once a team's stable, you're going to get to a point where any minor change is likely to be detrimental. It's going to move you down that slope in one direction or the other. But what happens if you want to get further away? So you can see that there's a better process available, but there's no smooth path to it. So the question is, are you willing to take those hits on the way to get to it? Or can you find some way to jump from one of these peaks to the higher peak further away? The second reason it's hard is that it's going to need investment. And that means you have to make a case for that investment. So you often can't ask your leadership team, can I have funding for a 2-year project? I'll let you know when it's done. So this is really about how do you build confidence and how do you build things like metrics to be able to prove that things are going well and that your change program is worth continuing. So that's really planning up front exactly what metrics would you need to show management every month to get their confidence that their money's well spent, and that's not easy to do. Collaboration, positive thing, but complicates things here. And what I'm really thinking of is collaboration with departments outside the engineering teams. So take marketing. If you've been training them that you're going to release a product every 4 months or every 6 months, it's going to have a load of new features, and it's worth their time investing in those, researching those, getting some nice marketing material, and then you suddenly switch to releasing new features every week that they didn't even know were coming. That's not going to go well. So you need to work with all the other departments, sales, licensing, and make sure that they're on board for this change. And then finally, architecture. Our job as architects is to look at the functionality needed, look at the teams and their processes, and come up with a design that will achieve the functionality most quickly, most efficiently. Problem is, if you then completely switch your processes, the designs won't be so well aligned. So what was a great design for that team of experts is going to be less suitable for a continuous delivery style team. And an obvious example is testability. If there was no need to design code for testability from day one, you're not going to end up with testable code. It's going to be very hard to add those tests in. Despite that, we decided to go for it. And we launched a project to try to almost switch our process from that team of experts to the continuous integration. So number one goal was to get test coverage to a high enough level that we had virtually no manual testing or any other process for a release. So we could just take any release that's passed our build pipelines and give it to customers. The second aim was, while we're doing that, let's take advantage of the change and more closely realign the product's architecture with the current functionality rather than what we were offering in 2008. But we found ourselves in a bit of a catch-22. So I think it goes without saying, you want a high level of test coverage before being confident in making big, sweeping changes. But on the other hand, this is a representation of an internal product architecture. So different colours of different components, how they fit together. Now imagine you write tests, which is the orange outline for one of those components, but then you change the product architecture, which we wanted to do to realign with functionality. That test is then not particularly useful. It won't work with the new architecture, at least not unmodified. And if you have to rewrite all your tests, why write them against the old architecture in the first place? So we end up thinking, on one hand, we need to test before we can make the changes. On the other hand, we want the changes before investing in the tests. We had to work out how to solve that. So one possible solution, let's do them both together. Let's write the components, write tests for them. It'll all be good. Which could well have worked, but what we're really talking about there is a complete product rewrite. You can't do it component by component if the boundaries are changing. So it would be a case of start from scratch, write the product again. And just the risk of that is unacceptable. Sometimes it works, often it doesn't. But we needed an approach that was much more guaranteed to work rather than one that may work great or may get cancelled after 18 months. The other suggestion was treat the whole thing as a black box and write sort of end-to-end tests, sort of using browser automation. And I think that would have worked for some products, but not for us. There's kind of two reasons. One is we've got to test this advanced database engine with all the millions of possible different queries users could throw at it. And it's not practical to do that by simulating mouse clicks and mouse drags and that kind of thing. A secondary reason was at the time we wanted to experiment a lot with changing the way the UI worked, and we had a UX team involved. And in my experience, if you build up too much testing in terms of browser automation, or the equivalent, you kind of add a tax to every change you want to make to the UI because you need to update tests. So you can update those tests, but what it means is every UI change is a little bit more expensive than it would have been otherwise, so you tend to make fewer of them. I didn't really want to be introducing that kind of cost into the system. So in the end, we did a little bit of both, describing this as a layered approach. So this was our original architecture. So a bit of JavaScript code running in the browser, lots of Java code in the server, and those streams of WebSocket messages going back and forth between them. So the first thing we did was to identify the real core components, so things like our query engine, our security code, and we just took copies of those. And we get into a team, and we said, write this in the ideal way, change the structure, do whatever you want, just give me a high quality version of that component that's well tested. But we kept it separate, and we thought we'd work out how to integrate it later. We then rewrote just the JavaScript, the browser code. So all the stuff running in the web browser. We actually changed from JavaScript to TypeScript, but that wasn't the important thing. The important thing was to separate out all the business logic for anything that interacts with the browser. So you see where it says DOM, if you don't know, it's document object model. That's just the browser-specific code. But 80% of it we could also use as an API for a new test framework. So we wrote that test framework, and now we could write tests directly, and they would go through exactly the same code path on most of the browser code and all of the server code as users actually run. Now, these tests were still pretty painful to write. They tended to be send a sequence of events to the server and then wait for a sequence of messages to come back and hope eventually, no matter what order they came back in, things look good. So I have to say, quite painful at times writing those tests, but they did let us get far enough to get some confidence that if we were to change the server code, it was still working. That was true particularly the top layers of the server, the bits closest to the browser. So at the moment we weren't too focused on checking things like our query engine. It was more about the user interaction with the server. And we got to a point where we had enough test coverage that we were confident to refactor a whole layer of code towards the front end of our server. Once we've refactored that and abstracted out all those WebSocket message passing, we could then write a second test framework, this time running in the same process as all the Java server code. And that was a really big win for us because, first of all, we're more familiar with the Java language, but also once you're in the same process, you can observe a lot more about what's going on, and you're avoiding that asynchronous message passing. So we could write tests at a sort of order of magnitude higher rate than we could when we're relying on them running outside the process. So after that, we got writing tests basically to make sure the server was doing what we thought. And at that point, we began to start refactoring more, rewriting some of the more small components, each time sort of securing them with lower and lower levels of tests. So it got to a point where a lot of the tests we wrote originally up in that TypeScript layer, we could remove. They were almost there for scaffolding. We needed them for just long enough for us to write lower level test frameworks and APIs. And after that, we could rewrite those in a more efficient level, and they were redundant. So we still have some tests that need to test browser server communication, but all the tests that aren't really relevant to a web browser, we can move from the TypeScript layer down into Java. And then finally, we could take those rewritten core components like the query engine and move them in to the new product. And again, be completely sure they worked. We tested the component itself thoroughly, and having these various levels of frameworks in place meant that we were now confident that the integration worked. So to summarize, we started off needing a process change. This wasn't about technology change for its own sake. We needed to be able to scale our teams. We had a lot of market demand. We needed to build more features, and we wanted to be more agile. We didn't want to have to wait several months between releases. We worked out the blocker to that was really around test automation, and that's what we needed to fix. And as a result, completely changed our technical architecture, moving from one that was geared originally on how do we write functionality quickly, prove market fit, to how do we have one that's as easy as possible to write comprehensive tests for. And so the results turned out to be roughly an 18-month project. We're now at about a week between releases, where we were months. The reason we don't go much more frequent than that, well, there's two of them really. One is most of our customers are on-premise, so there's not a lot of benefit to giving them daily builds. They're not going to install them that often. But also some of our performance tests can take hours or days to run, so we save a bit of resources by only running those weekly. We've moved entirely, or very nearly entirely, to a continuous integration model with just one main dev branches and no long-lived feature branches, which is kind of representation of how development processes change to match our testing processes. About 10,000 new tests were written, I counted the other day. We scaled from one team in one location to 6 teams. I was going to say in 3 locations, but thanks to COVID, where everyone's got their own office now, so very distributed. And in terms of structure, we previously had one main modular code. We've now got around 50. I think that's relevant for 2 reasons. One is that it shows how much we have changed the structure, and the other is it just shows that we had a lot more functionality. So a lot of those modules represent brand new things we've been able to build quickly that we wouldn't have otherwise been able to build without all the test automation in place. So that's everything. I'm going to be around to answer any questions. but I hope you found that interesting.